Welcome to Build Theory. In this series, I am building a 12-valve Cummins-powered Ford Explorer 4x4 project. Last episode, we cannibalized the lifted suspension out of my old high school 4x4 in order to use it in this project. In today's video, we're going to get the suspension mostly buttoned up, and we're also going to explain the ins and outs of guesstimating practical suspension design. So, let's get to it. First thing is first, I need to install the lifted coils. While I'm doing this, I want to take measurements of the suspension travel so that I can be sure to position the shocks properly in the chassis. I need to measure the maximum shock length at full suspension compression and the minimum extension at full droop. Then I can begin working on the shock mounting brackets. Alright, I've made a plan. I'm going to make a plate that bolts on to the upper and lower radius mount arm, and in the middle of that plate will be a stud to bolt the shock to. After cycling the suspension up and down and everything, I think that'll work great. The best thing about that is that I could remove it and modify it or anything if and when I end up getting better shocks and springs and everything for this. It's not actually permanent. I can easily make another plate for a better shock in the future. Full droop both sides. Now we've really got a bit of that flying TTB look going on. On the shock mount brackets that I'm making, I'm going to reuse the stud from the old radius arms. Just about fits, but I need a small spacer in there. This side is really tight. So because the pumpkin's over here, I don't actually have a lot of room on this side. But I came up with a solution. Let me show it to you. So this is the solution I came up with. In order for the shock to fit here and still have some clearance on that bolt, I actually sunk the bolt in like that to give me an extra 1/4 inch. And if I need even more clearance, I can even grind the top of the bolt off. But now this bolt is permanently attached to this bracket. So what I can do is slip that one in. And then I can slip that in. And then the final bolt, of course, can go in there. And that's what I'll have to do in order to slide this shock in here because the space is so tight right here. But it does go in. So there it is. That's what the bracket's going to look like. I just need to throw some paint on the bracket. But there's still one issue here. These extended shocks, I'm not a big fan of them. So I'm not really happy with these front shocks. They don't give a lot of travel. They're in a little bit rougher shape than I remembered them being in. And most importantly, with 5 inches of shock travel, I would only end up with about 8 inches of suspension travel. And this suspension's capable of a lot more than that. Really, I wanted to get the Explorer running before I go crazy trying to build insane mods to the suspension and all this other stuff. However, with the state of those shocks and with how much more difficult it's going to be to use those shocks, I needed a solution. I was actually able to find some rough country shocks though that are for an F250 or F350, which is what this axle came out of. And the ones I found from rough country are only $90 and have 10 inches of stroke, which is double what those ones have. So that's what I'm going to do. I'm going to buy those rough country shocks. I don't know if they're going to be here before this video is over, but for now I'm just going to keep mocking it up with these Ranchos, but just keep in mind that the front is going to be getting some longer shocks. Now, the rear, on the other hand, the rear I probably am going to stick with the Rancho shocks for now, because I don't think this is going to be the final state of the rear end. I don't want to make any promises, but this rear end might eventually end up, well, let's just say very modified from where it is now. Let me make another bracket like this for the other side, and then let's get the rear shocks in. I've been doing so much stick welding lately, I kind of forgot how much I like TIG welding. Now, if only argon weren't so expensive. There's this shock bracket for the other side. Now it's time to move on to the rear. Let's start working on the rear end. All right, I figured out what I'm gonna do on the rear here in order to mount the shock. This Explorer originally came spring under axle, meaning that the 48.8 inch that was stock in this sat here above the spring. When I swapped to the Dana 70 out of the Ram 2500, I opted to put the spring over the axle. That lifts the Explorer by the height of the spring pack plus the perch. Since I just want to use the stock shocks in the rear for now, I'm just going to put the shock mount where it was stock. Basically what I'm going to do is I'm going to cut this down so that it's flush and just mount this to the top of the spring pack there. That way the shock is still in the stock location. I haven't changed anything about the way the axle is going to move or anything. So this is what I'm starting with, and all I did was I took and I cut it up, so now it looks like this. And then that U-bolt for the suspension will go through it. And now this shock mount is exactly where it was stock. So this will work fine for now. And once again, I can easily change this later. I'm not welding anything on or anything. It's not permanent at all. So this will be a fine solution for now. It's not a great permanent solution, but like I said, I need to actually drive this Explorer to get an idea of how I would like it to ultimately end up. So the only thing that separates this from stock now is that the axle is wider and it sits a little lower in the chassis. That's going to give the axle a little bit more leverage on the stock suspension. That's the equivalent of removing some damping from the suspension. So ultimately, all the changes I should make should end up with this being stock-like, except now with a heavier and wider rear end, it's going to feel like the rear end is softer. All right, here's all the shock mounts done. This is the front, this is the back. My shocks are here. Let's open them up. Something about new parts. Well, that looks like it's going to be a bit of an upgrade. This is what the old one looked like. I think that's going to be a huge upgrade. Now the measurements on this shock, it should be slightly longer when fully compressed, but the extension is way further. Anyways, this should be a nice upgrade. These were only $90 for the pair of them, so $45 each. So these, if I remember right, were about the same cost of these, and they have a 10-inch stroke. What I did to find these was I just went to Rough Country's website, and I looked at every shock they had for a Ford, and all I did was I looked at all the measurements of every shock they had, and what I ended up with was the shock out of an F-250, which is perfect because F-250s came with big diesel engines, so I'm hoping this will have a lot more damping than this one does, which I need more damping because I'm putting a much more massive engine in it. So hopefully this will be a good shock for it. We've been talking a lot about vibrational systems, like when you have springs and dampers and all of these things. I thought I should give a quick explanation on them. First off, this shock absorber is more generally known as a damper, not a dampener, a damper. This isn't trying to make the vibrations damp, it's not trying to make them wet, it's trying to damp them, it's trying to lower their amplitude. So this is a damper, and it damps, not a dampener, and it doesn't dampen. Now there's a few components to a vibrational system that you need to know in order to define that system. The first thing is a spring. The second thing is a mass. And then the third thing would be a damper of some sort. Now in this case, I don't have a contrived damper to use for this system, so we'll just say that the natural friction in the spring and the natural air friction, that's what's damping this system here. So you'll notice, if I give it a little initial energy, then it oscillates. Notice how it keeps oscillating up and down and up and down? That's what we would call an underdamped system. It doesn't have enough damping to lower the oscillation to where it stops oscillating. It'll stop eventually because there is some natural damping, but you wouldn't want your car suspension to do that every time you hit a bump. So damping is basically the amount of friction or resistance to movement that's in the system. Now there's underdamped. What about overdamped? Here's an example of overdamped. If I were to set this crowbar on the table and try to oscillate it here, then there's a huge amount of friction between the table and the crowbar. So this should end up being an overdamped system. There's way too much friction. And as you see, there are no oscillations whatsoever because there's too much friction for it to oscillate. The other thing you might see though is the friction of the table slows it down so it doesn't return to the stationary position as quickly as it could. So that's an example of an overdamped system. What about the spring itself? These springs we measure in pounds per inch. Now this spring here, you can see I have a 5-pound crowbar on it and it deflects 1.5 inches or something. It's probably a 2.5 pound per inch spring. The spring on your car, for example, this stock Explorer spring, this is probably something like a 200 pound per inch spring or something. So if you were to put 200 pounds on it, it would deflect 1 inch. If it were to deflect 2 inches, that would mean that it's holding up 400 pounds. That's another variable that you can change when you're trying to get these systems to do what you want. And the last variable is, of course, the mass. If I were to take this heavy mass here, notice how it slowly oscillates up and down, and it oscillates a bunch of times. If I were to lower the mass while keeping the spring rate and the natural damping the same, notice what happens. Because the mass is lower but the spring rate's the same, that's similar to having a higher spring rate. It oscillates very quickly. Also, because the mass is different but the damping is different, it's almost like I have more damping in it. So it comes to rest quicker. So just by lowering the mass, I effectively made it oscillate more quickly, I effectively raised the spring rate, and I effectively added damping, which made it come to rest quicker. So you can also change the mass of your system to get it to behave how you want. Those are the 3 variables that you can tune to get your car suspension to behave how you want: damping, spring rate, and mass. Now, it's a little more complicated than that because these are dynamic systems. It's not just one static, similar excitation that's happening. There's all sorts of excitations that are happening to your suspension as you're traveling down the road. But this is the basics. Now, what exactly are we shooting for in a car? Well, we talked about overdamped and underdamped. If we want maximum control over this vibrating system, that would be something called critically damped. The way that critical damping works is you want enough damping such that it does not oscillate. However, you don't want too much damping to where it slows down its rate of return. So you want it to go from the extended state to the stationary state as quick as possible without overshooting and oscillating. That is the objective. That is called critically damped. And that's actually what you can measure on your car. The standard way to test your shock absorbers on your car is what you do is you bounce the vehicle and you let go and you see if it oscillates at all after you let go. What you want to see is you push it down, let go, and it comes up and stops and it doesn't overshoot and oscillate. In a car, typically you would want one cycle. If there's any more than one cycle, you'd say your shock absorbers are bad. It's hard to see on this chassis because it's wiggling side to side a lot, but that's called the jounce test. So you would jounce the suspension like that and see if it returns. In this case, to me, it looks like it's very harsh and very jagged, and that's because it's also oversprung. This is too much springs for a vehicle that's just a steel frame that doesn't have a body and an engine in it. So those are the three variables you can change: the amount of damping, the spring rate, and the mass. And what you're trying to achieve is a critically damped system. That's what all this playing with suspension is about. And that is basically Vibration Systems 101. Obviously, it's a lot more complicated than that, but those are just the basics so that we can all have the same language when we're talking about it and we know what our goals are. Now I want to talk about the choices I made on the front and rear in this so that you get an understanding of why I made them. For example, on the rear of this vehicle, I effectively raised the mass and kept the damping and the spring rate the same. The way I did that was by using a heavier rear axle and one that is wider, and that effectively increases the mass a lot. Now, I did that intentionally. I think that stock, the rear on these things, actually feels really stiff, and so I'm hoping that by using the same damping and the same springs and everything, that the rear end feels a little softer. But on the front, I added a lot of mass. I'm putting a Cummins in the front. I added a lot of mass. So because I'm doing that, I would want heavier springs, and most importantly, I would want more damping out of my dampers. I would want shock absorbers that are built for something that has more mass. And that's why I ended up going with shock absorbers out of an F-250 on the front, but I went with stock shock absorbers on the rear. And ultimately, I'm not going to be able to figure out what's best until I actually drive the thing. The issue is that I don't know any of these values. Maybe I could find the spring rate for some of these things, but as far as I'm aware, nobody posts their damping coefficients. One reason why is because most of these dampers, most of these shock absorbers have 10 different valves in them, so you would need 10 different settings depending on how quick it's moving and everything else, so it's really hard to post that. They could give you a chart, but as far as I'm aware, they don't. So I don't know the damping coefficient, I don't know the exact weight, the exact mass, and I don't really know the spring rate, though I might be able to find it. I don't know any of these values for this car. So right now I'm kind of just guessing. But ultimately, the way that you sort this out when you have all these unknowns in a vibrational system is you have to measure the thing. So what my intention is I want to get it all fully put together and go drive it and take some measurements and see how it acts. And by doing that, I don't need to know all of the coefficients for everything, although I could actually estimate them if I could take good measurements. So my goal right now, as it's always been, is to get a running, driving Explorer. I don't want to try to set up the suspension fully right now when there's so many unknowns. This is a Cummins and an Explorer. Nobody's done this before. I just want to get this thing together and running so that I can feel it out and feel out, okay, well, maybe the front feels fine, I need to do a lot of work in the rear, or maybe it does feel a little too stiff or a little too soft, how do I fix that? That is the goal right now, just get it running, get it moving, and then the major suspension modifications will happen later, once I know what I want out of the vehicle, and once I know how it feels. So, I just wanted to explain that real quick. Hopefully that quick overview on vibrational systems makes a little bit of sense, and hopefully that helps you understand why I'm going at this the way I am, where some parts of this I might be doing might be a little bit of a bodge for right now to get it going, but then other parts of it I'm not skimping out on at all. Hopefully that helps make a little more sense. I was all excited to start getting the new shocks in, but unfortunately, I have a problem. So let me show you what's going on. So this is one of the old shocks, the lift shocks from the Explorer. And the issue I'm having is that this is basically maxed out where it sits here. In fact, to mount this, I had to tie a ratchet strap on here to compress the spring a little bit to even get the nut on the top. So this shock is a little too short. I knew that when I ordered the new ones, which is why I got some longer ones for the other side. I had to take a bit of an educated guess on what size to get here. And you can see with where it sits right now, I'm almost fully compressed on this shock. It does give me the droop that I wanted, of course, like from the other side, and let me show you the comparison now. You can see that on the other side, I got maybe 3/4 of an inch before the coil maxed out, whereas on this side, I'm getting a full 2 inches or more before the suspension's actually just hanging on the coil. So I'm getting a lot more droop out of this, which is what I wanted, but this part of the shock is too long. So the old shocks are too short and the new shocks are too long. I sort of knew that something like this might happen when I got this, but the biggest reason I wanted to try and make this work is because this thing has a 10-inch stroke, which is a ton. So in order to make this work, what I need to do is just extend the shock tower. I just need to make that longer so that I have a bit more travel in the shock so that I can bottom out on the bump stops rather than bottoming out on the shock. I was all set to get to work on building a new shock tower for it when I realized I probably shouldn't do that right now. First, I don't actually know what the ride height of this thing is going to end up being. I need to get the drivetrain in and the body on so that my suspension's sitting at ride height. Not only do I not know what the ride height's going to be, I don't know if this thing is level yet. Because I did a spring over axle swap in the rear here, I lifted the rear about 5 inches, and on the front I have like a 2-inch lift spring as well as a 1-inch body lift to fit the Cummins under the body. And then because my axle is wider and bigger, I'm ending up with another 1 to 2 inches there. I'm guessing that I'm only around 4 inches, maybe 4.5 inches of lift in the front. Now, if my rear springs were a little bit droopy, I'm probably level. But it's entirely possible I need to lift the front another inch. And if I need to lift the front another inch, I definitely don't want to build extended shock towers just to lift it more and have the shock in the wrong position again. What I've decided is this is a future build theory problem. For now, I'm either just going to run it shockless or run the old shocks. And then once I get everything back together, then I'm going to fabricate a new shock tower mount. Once I know for sure that the front is going to be level, and once I know for sure what the ride height's going to be with all the weight on the car. Next time, it's back to work on the drivetrain. So, thanks for hanging out with me in my garage today. Like this video if you liked it. If you want to see more, then subscribe and stick around, and hopefully I'll see you next time.